Okay, let's get started. Welcome everyone for this Gradle 8 release presentation. Gradle 8 is the first major release since Gradle 7. It's been almost like a bit more than a year and a half between the two releases. And so what we're gonna do today is we want to cover the release itself, its features, but also do a recap, because we usually consider that a major release is effectively a way to bundle all the goodness that was introduced in the 7x line. And then we'll get to the engineers presenting the different features of 8.0 specifically, and then talk a little bit about some of the upgrade guide logic and things like that we have in store. So 8.0 released on February 13. We've had a couple RCs. You'll see that we have quite a number of commits, like nearly 4K, more than 200 issues that have been fixed, and a huge number effectively of changes. Some of the highlights: improvements to the Kotlin DSL, we have configuration cache performance benefits, and we're also looking at build source more, like included builds, but also the ability to clean up the Gradle user home caches. Quite a few external contributors participated into that release, so that's always great to see the community helping us and fixing issues. So thanks to all of them. We also had a special event during the 8.0 preparation. There was a configuration cache hackathon, where the idea was to tackle specific issues related to configuration cache support. We had quite a number of participants in there. And the event was also run with a bit of a contest, because participants could vote for their best overall PRs. And we congratulate Bjorn, Dennis, and Vinay for making it to the top. So as I said, we'll start with looking at the journey from 7x to 8.0. I should have updated that slide. The upgrade guide will do last. Then we'll go over the different features, the Kotlin DSL, the build source changes, the configuration cache improvements, the Java Toolchain improvements, more general improvements, and then code quality plugin improvements. So when we look at the journey, we actually add 6 minor releases in the 7x line, so 7.0 all the way to 7.6. And if we look at some of the highlights of those releases, Gradle 7.1, which had 1 patch release, was mostly focused on revamping the incremental compilation, where we store actually the result in the build cache, allowing to restore from incremental compilation state and then continue use incremental compilation even after a cache hit. It's also faster, takes less memory and disk space, and now handles changes to constants thanks to a compiler plugin. We also enhanced the generation of Kotlin accessors so that source sets are easier to configure and you no longer need the with convention. That was the trick before to get to the specific type of the source set. Then Gradle 7.2, a couple months later, and like mid-August 2021, we added toolchain support for the Scala plugin, so that mostly Scala compile and Scala doc. Our build cache got more hits because we introduced an annotation for line ending normalization, and it's applied to the Java plugin. And so that allows effectively checks out on line feed and line feed carriage return systems to be normalized, getting cache hits across these OSs. We also have a more resilient HTTP build cache behavior that allows it to continue leveraging the build cache even if it sees a number of HTTP problems. Gradle 7.3 had 3 patch releases. It introduced the test suite DSL, which is an interesting evolution in the way we see DSLs in Gradle, and we want to have more DSLs like that. We also had support for Java 17 in there, support for Scala 3, and the file system watching that was introduced, or at least made enabled by default in 7.0. So a few improvements to its robustness, covering more exotic file systems. Then Gradle 7.4 with 2 patch releases. That's where we introduce aggregation plugins for the test and Jacoco reports. The test suites were enhanced so that if you have a project leveraging them, you will see them as test sources in IntelliJ without having to configure anything specific. And then toolchain provisioning, we had to handle the migration from Adopt OpenJDK to Adoptium, which caused some changes into the download endpoints and also the vendor names effectively. Then 7.5, one patch release, we introduced support for Java 18, building Groovy 4 projects, instant continuous build. That's because we revamped the continuous build implementation to actually be file system watching based. And so we no longer have the downsides of some of the JDK APIs for watching file systems. And we enhanced greatly the dependencies and dependency insight reports so that you can diagnose dependency resolution results much better. Then the last release in the 7x line was Gradle 7.6 on November 25th. We have support for Java 8.19 in there, an individual rerun flag for task that allows you to rerun a specific task, effectively ignoring its up-to-date state. We have an improved dependency block for test suites, which is much better, especially in the context of the Kotlin DSL, because it uses different strong types, and so will guide you better to what you can do with those dependencies and integration with the version catalog and other source of dependencies. And then finally, we released a big enhancement around Java Toolchain's provisioning, which is plugin based and effectively allow you to plug a provisioner for Java Toolchains, opening up the sources of Toolchain's auto provisioning effectively. So that's it for the journey. Quite a number of things. All of those are considered stable effectively in 8. And one thing that I did not mention, because it would be an item in each and every release, is that great attention has been given to the configuration cache during the whole 7x line. And so the configuration cache in 8 is definitely a well-advanced beast compared to what it was in the past. And we'll have even more details on that in the rest of the presentation. So let's head on for the Kotlin DSL. I think that's Paul, right?
Yeah, that's me. So we need a number of improvements to the Kotlin DSL in Gradle 8.0. The first one is improved script compilation performance. And that's the next slide. Yeah, thank you. And it's about, so it's one step in our journey to make the Kotlin DSL script compilation faster. And it's about the plugins block itself. In this release, we introduced an interpreter that allows to avoid calling the Kotlin compiler for the plugins block. And it provides an overall script compilation time improvement of 20%. In this release, it supports a part of the constrained syntax of the plugins block, and that's simple plugin request with just an ID or an ID and a version and or apply false, and the Kotlin shortcut. And when the interpreter encounters either plugin spec accessors, like you can see here for the Acme plugin, or version catalog aliases, it will fall back to the Kotlin compiler. We will add support for this too in future Gradle releases, but what it means today is that if you use either plugin spec accessors or version catalogs, you won't get the performance improvements, but we'll get there. The next one is that we upgraded the embedded Kotlin to Kotlin 1.8. And so we were able to update the Kotlin DSL API level and language level for Kotlin to 1.8. The Gradle 7.x line was on language 1.4. So with Gradle 8, you get all the improvements that were made to the Kotlin language and standard library, Science 1.4. And this includes some goodness. Here is just a small list, exhaustive when statement, pretty useful in light classes, silk classes. etc. And those things, we will now be able to leverage them in future Gradle versions to make the Kotlin DSL better. And it also means that you can use libraries that leverage Kotlin language 1.8 in your build logic now. We are limited to 1.4 before. Okay, so the next thing is that the two next things are related, and the first one is that we made the script compilation use the JVM you use to run Gradle as the target. Before, we were fixing this to Java 8. And so now, with this change, you can use libraries that leverage more recent Gradle versions, more recent Java versions. And if your team, if everybody on your team is using Java 17, say, it means that your build logic can leverage Java 17 only libraries, or Kotlin libraries that were compiled to target Java 17 only, for example. So this is about the standalone scripts, like the setting scripts, init scripts, and the build script. And the next one is about precompiled script plugins. So that's the ones that you would ship to the plugin portal, for example, as binary plugins, or that you would have in your build logic, build source, or included build. And those ones in the past were always using Java 8 by default, and you could set them using JVM target to use another Java version. And now with Gradle support for toolchains getting better, and the Kotlin Gradle plugin itself leveraging Gradle toolchains, our support for precompiled script plugins now does the same and leverage Gradle toolchains. And that's the snippets below is how you configure this in your build. That's it for the Kotlin DSL. And I think next we have the improvements to build sources and a recording from Adam.
Gradle provides two different ways that you can use to implement plugins and tasks that can be used within your build. The first of those is the build source directory, and the second is using an included build. In Gradle 8, we've taken features that included builds have had for a long time and made them available for build source. So the build source now becomes basically an implicit included build. So the first of these changes is that Gradle does not automatically run the build source tests unless they've been explicitly requested. So this can save a lot of time for developers who are just working on the software and not interested in changing the build source implementation. Here I've got a build with a build source directory. It contains a plugin implementation and a bunch of tests that are quite slow. Let's run this with Gradle 7.6. So you can see here Gradle is running the tests and they're quite slow. And then it goes and builds the project. Let's try the same thing with Gradle 8. So you can see here it skipped the tests, it's just built the jar, which is all it needs to do. So it's a lot quicker. So what if I actually want to run the tests? Well, Gradle now allows you to run build source tasks from the command line and from the IDE. So with Gradle 8, I can just list the tasks on the command line, just like any other task, and Gradle will run them. So you can see it's running the tests. So Gradle now Gradle provides two different ways that you can use to implement plugins and tasks that can be used within build with a build source directory. So what if I actually want to run the tests? Well, Gradle now allows you to run build source tasks from the command line and from the IDE. So with Gradle 8, I can just list the tasks on the command line, just like any other task. Gradle will run them. So you can see it's running the tests. So Gradle now applies init scripts to build source build, just like it does for included builds. So this can be useful if you have an init script that you use to inject configuration into your build. So let's run the build with Gradle 7.6 and apply an init script. Running the test again. So you can see the init script has been applied only to the main build. So if you want to inject configuration into build source, this isn't going to work. So let's try the same thing with Gradle 8. So you can see here the init script has been applied to both the main build and to build source. Finally, build source can now include other builds. So this is useful if you have some shared convention plugin that you want to apply to your main build and also to build source. Here I have another build. It has a build source directory, but it also has an included build with a shared plugin. Let's take a look at the settings script for build source. So you can see it includes the settings plugin build and then applies the settings plugin. Let's try running this with Gradle 7.6. So you can see it blows up saying that you can't include builds in build source. Let's try running this with Gradle 8. So you can see here it's built the shared settings plugin, it's applied it to build source, it's built build source, and then applied the shared plugin to the root build.
So back to Adam again, but this time about the configuration cache.
Gradle 8 includes some performance improvements for configuration caching. In previous versions of Gradle, tasks would run automatically when configuration caching was enabled, only if Gradle could reuse the configuration cache entry, so when there was a cache hit. However, when there was a cache miss and Gradle needed to recreate the configuration cache entry, it would not run the tasks in parallel. So now in Gradle 8, Gradle will always run tasks automatically in parallel when configuration caching is enabled. And this includes for cache hit builds and also cache miss builds. So this happens regardless of whether you use the -- parallel option, and this behavior will eventually replace -- parallel. Here we have a build with configuration caching enabled, and the build defines a number of tasks that take some time to run. So let's try this out with Gradle 7.6. So here we get a cache miss, and you see Gradle's running these tasks sequentially rather than concurrently. Let's run that again now and see what happens when we get a cache hit. So you see now Gradle 7.6 is running those in parallel. Let's try this out with Gradle 8 now. You see Gradle gets a cache miss, but it still runs those tasks in parallel, and it's a lot faster. We run this build again, and we get a cache hit, and the tasks run in parallel. This change also makes it easier when you are working on migrating your build to be configuration cache compatible. Gradle can now detect deserialization problems in cache miss builds, whereas in previous versions, you could only do this for cache hit builds. So what that meant in practice is that after you made a change, you needed to run the build twice to be sure that you've seen all the configuration cache problems. And now you only need to run the build once. So this is a big improvement for feedback time. So here we have a task implemented in dynamic Groovy that accesses the project state at execution time. Now this isn't allowed when configuration caching is enabled. So let's see what happens when we run this with Gradle 7.6. So we get a cache miss and Gradle says build successful, everything's okay. However, let's run that again and get a cache hit this time. We can see that the build blows up because of the problem in the task. Let's try the same thing with Gradle 8. So you can see here Gradle gets a cache miss. However, it also reports the problem from execution time. Finally, this change also means that Gradle can release all of the heap that it uses at configuration time before it starts running tasks. And this can really reduce the maximum amount of heap that Gradle requires to run your build. Here we have a build that allocates a large amount of heap at configuration time, and then also has a task that allocates a large amount of heap at execution time. Let's try this with Gradle 7.6. And you can see the cache miss build blows up. Let's try this again with Gradle 8. So you can see here, again, we get a cache miss. However, the build succeeds because Gradle is able to release all of the heap space that's allocated at configuration time before the task goes and allocates a huge amount of heap at execution time.
Okay, that was it for the configuration cache. Code quality plugin improvements. I think you're up, Gary.
Yeah. So I'm going to talk about a couple of minor code quality plugin improvements that we had, and then we'll roll into some more general improvements to Gradle that kind of cross-cut a number of different features, and I'll talk about the first one of those. So go ahead. So the first thing that we did here is that with the CodeNarc plugin now detects the Groovy runtime version. So the idea is that if you're just using the default CodeNarc version, it will detect whether the runtime version of Groovy is 3.x, and if so, it'll use the 3.1.0 version. If it's 4.x or above, it will now use the 3.1.0 Groovy 4.0 variant, and you won't have to worry about this. This is only applies to default, of course, and so if you're using the tool version setting to configure your own version, you can still do that, and it doesn't have any effect on that. Go ahead. Yeah. And then the other thing that we did with code quality is we made some improvements to the PMD task. And so whether you're using configuration cache or not, PMD tasks will now run in parallel or execute in parallel by default. So you could potentially have multiple code quality checks that are running at the same time on the same project, and those will execute in parallel now. The other aspect of this is that PMD now runs in a daemon process. So it runs out of process. Previously, it ran in the build process itself. Now it runs in its own daemon. And one of the benefits of this is that it will detect the Java toolchain that you have configured, if you've configured it. And so, for instance, if you're running, or had set the toolchain to use the Java 11, the PMD process will also use Java 11. So I'll automatically align the PMD process with the version of Java that you're using for compilation and testing and such. So it's one more stumbling block that you wouldn't have to worry about now, because all of those things are aligned, as opposed to, previously, if the build tool process was maybe running in a different JDK version or Java version, you could potentially have conflicts there. Go ahead. Okay, and let's talk about some general improvements, and I'll start out with the some changes that we made to cache cleanup. So since Gradle 4.x, Gradle automatically cleans the caches in the Gradle user home directory. And what this does is previously it would use a fixed threshold for inactivity. So it's either 30 or 7 days, depending on which cache it is. And what that means is that, for instance, if a particular cache entry had not been used for over 30 days, it would be eligible for cleanup when the cache cleanup executed. What we got some feedback from users is that those particular thresholds didn't work well for their use case, and so these are now configurable. And to configure them, what you would do is create an init script and put it in that Gradle user home directory under the initd directory, which, if you're not familiar with that, anything that's in that initd directory are init scripts that will be automatically applied to any build that runs using that Gradle user home directory. And in that script, you can set these thresholds. We've kind of broken them down into two higher level categories, and ultimately it's 4 different settings that are available to you. So the first are really version specific caches, and so the released wrappers and snapshot wrappers really they correspond to version specific caches associated with a particular distribution of Gradle. So when you use the wrapper, it downloads a distribution of Gradle, drops it into your Gradle home directory. And then what we do is we, at cleanup time, we look at those and then also remove any caches that are associated with that particular version of Gradle. And so if a particular released version of Gradle has not been used in 30 days or more, then it becomes eligible for cleanup, as well as any version-specific caches associated with that. So released wrappers corresponds to the threshold for anything that's a released version. Snapshot wrappers corresponds to the threshold for anything that is a snapshot version. Now, opposed to that, there's also caches that are not version-specific. They are shared by multiple versions of Gradle. And so the downloaded resources are any sort of cache entry that we go out and download, from an external source. So, for instance, the dependency management cache is kind of the biggest one there. On the other hand, we also have what we call created resources. These are anything that's created by Gradle as part of the running of the build, and those created resources are things like artifact transform cache. We do that. So those were previously had a fixed interval of 30 and 7 days, respectively. Now you can configure them to whatever makes sense for your environment. One thing to note is that this can only be configured in an init script in your initd directory of your Gradle user home. And the reason why we did that is that we want to couple this configuration with the Gradle user home directory itself. And we want to avoid a situation where maybe you had multiple projects that maybe had different settings that conflict, all using the same Gradle user home directory. And then in that case, which one wins out and such. So by putting it into that Gradle user home directory, these threshold settings are all coupled with the Gradle user home directory itself. Okay, next slide. And then the other thing here is around the frequency of cleanup. Previously, you could disable cache cleanup. It's enabled by default. You could disable it by setting a property in your Gradle user home, Gradle.properties. Now you can also set it via the DSL as well. And again, this would be in your initd directory in an init script. You would configure this cleanup equals cleanup.disabled to do that. Now, previously, the property that disabled it would only disable cache cleanup for those version-specific caches. There was no way to disable cleanup for those shared caches that are shared by various different versions of Gradle. Now this setting applies to both of those. You can continue to use the property in the Gradle.properties, but you can also set it via the DSL, and eventually we'll deprecate the property as a way to set it. And that's it for the Gradle user home cache cleanup. I think Joseph is next.
Yes. So The toolchain download repositories, which were developed and introduced in 7.6, become the only choice to configure toolchain auto provisioning in 8. And this goes together with, this happened via removing the Adoptium and Adopt OpenJDK downloaders, which were the legacies at this point. And there is no equivalent repository plugin to replace them. We have developed a new toolchain resolver called the Fuji resolver. And even though this feature was pretty much finished in 7.6, it had a second round of improvements for error messages and naggings and documentations by the time 8.0 was released. Next slide. And another improvement is for warnings when running the builds in command line. When we were printing the warnings the build was generating, we printed all the unique messages only once, but this uniqueness was only based on their message text. And now we also consider the source where they come from. So basically the stack trace to figure out what script they are generated in. This is an external contribution. And that's pretty much it for my side.
Okay, now to two small features, new features for dependency verification. So dependency verification metadata got reason on two new places. So now you can set a reason why you trust some artifact, and additional to that, you can also add a reason why some verification type was used. For example, here you can see that we are using SHA-256 because Gradle Kotlin DSL plugins, that artifact is not signed. So yeah, with that, you can give some more information to future verification metadata maintainer why yeah, some you trust some artifact or why you use some verification type. Yeah. Okay, so next, and another small thing is that it's a bit easier to export trusted keys for dependency verification. Before Gradle 8, it was only possible to export keys when updating the verification metadata file, and this is sometimes a bit annoying because it's very easy to forget this additional parameter, this additional minus export keys. So yeah, you have to run updating the verification metadata twice. But now if you forget it, or for some other reason, maybe you can just run it as a separate command, and Gradle will export keys for you. So yeah, that's it for dependency verification.
Actually, one more item for dependency verification that I realized we did not mention. It's now mandatory to use full key fingerprint in your dependency verification metadata for any trust entry. That's done in order to make sure that you're not opening up yourself for collision attacks. And so that means that it's for the trusted. If you ignore keys, then you can still use short forms of short IDs or long IDs, because then the only risk you carry is that you effectively exclude more keys than you wanted. So that's one more change. Okay, so Gradle 8, aside from all these new goodness that the team presented, and thanks all for that, comes with a number of removals. And so what we've done for a while now is we always provide upgrade guide instructions as part of the deprecation messages. And we also encourage anyone wanting to adopt Gradle 8, if you see any kind of error, to go look at the upgrade guide. So the upgrade guide can be found in the documentation. We've got that upgrade guide, like upgrading Gradle section. It has a number of submenus depending on which version you're currently at and where you need to go. And then if you were, for example, to look at the version 7x to latest or to 8.0, you would see that we have entries from each and every version. And so the idea is that you may need to go through multiple of those stages depending on how many versions you're upgrading, and look at all the potential breaking changes, see if you're affected. Another strategy is, of course, to try out the version you're at, look at your deprecation warnings, follow the links to the upgrade guide to know what you're supposed to use instead of what's deprecated, and effectively do your upgrade that way. But so that's a resource that we really want to insist on being available. We've improved normally the whole process on deprecation warning so that it becomes mandatory to provide a link to the upgrade guide so that we don't forget it. But that's something that, yeah, you probably will have to consult if you were using deprecated features in 7x and want to upgrade to 8. And that's pretty much it. So